Hello once again. We are still dealing with sets and Venn diagrams. This is video number 2. We are getting more to the exciting part of sets. Okay, so let's get down to it. Drawing Venn. It Venn or Venn? I'm gonna say Venn diagrams. All right. So Venn diagrams are basically just diagrams that we use to draw or represent what's happening with this specific set, right? So let's say we have a set of something like that. I hate this circle. Okay, but let's say we have that. Okay, two circles. All right, so and then what we do is we give this one A and that one B, and let's say this, we have a number 1 2 3 4 5 6 7 8 9 10. Okay, so in this case this will be A, this will be B, that will be A. So if you were to write this down in the format that we had done in video 1, we would say that A has the following elements 1 2 3, and we would say that B has the following elements, which is 4 5 and 6. Okay, and how do we represent the universal set? How do we represent the universal set? Do you guys know how to represent the universal set? It's quite very important. So the universal set is usually represented by a long, it looks like a long U or something like that. Anyway, the universal set will contain, basically it's the whole, this whole rectangle. So everything inside the rectangle, all right, that will include 1 2 3 4 5 6 7 8 9, right, and turn. All right, so this will be the universal set that contains all those elements, basically, and you have A that only has these elements and B that only has that. Now if we are trying to find the intersect, you remember what we did? A intersect B, right? Since there are, remember this N is intersect, and what you also remember is elements that are in A that are also in B, and what we find is that there are no elements that are in A that are also in B, so the set is empty. Okay, you don't put any number there. The moment you put a number, it means that number, let's say you put 0 for example to represent that there is nothing, the assumption will then be that 0 is the actual element that is in A and also in B, which is not the case. Okay, so however, if we are to find the A union B, remember we just add all the elements in A are 1 2 3, and all the elements in B 4 5 6, so it will be this. Okay, now we have we can look at a few examples, but we also have what we call a knot. So let's say if we had to find the elements that are in A, we put on this thing and it becomes all the elements that are not in A. Okay, so if we know that 1, 2, 3 is in A, then everything else will be elements that are not in A, will include 4, 5, 6, 7, 8, 9, 10. Why? Because they are elements that are part of the universal set but are not in A. So this let me use another color. This little sign here will then tell us that elements, the following elements, are not in A, right? So ultimately that's what we are dealing with. Okay, and how about all the elements that are not in B? Some people tend to say B not. Okay, so will you be able to give that to us? So comment down below, make a comment, leave a comment of the elements that you feel are in B not. All right, so that is all for now. I want us to look at an extra or another Venn diagram that we will draw. We'll call this, let's call this A. So when you are leaving a comment, you are dealing with A. Okay, so let's draw another Venn diagram. Okay, so something like undo. Okay, so awesome. Okay, so let's say we have A and we have B. Why does it not pick up some of the things? So let's say A and B. I'm thinking out loud. Okay, so let's say we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 0. Okay, so my question will then be A, B, C. I'll say what are the elements that are in A, intersect B. What are the elements that are in A union B? And what are the elements that are not in A? Elements that are not in B. What about the elements that are in the union of not A intersect B? That will be interesting, right? So we're just going a little bit extra looking at these kinds of things. All right, so first step, let us see what are some of the elements that are in A, and so can we shade A? A would be all this. Okay, this is A, the whole of it. A, including the part that is also in B. Okay, so an intersect B. Okay, so the question is, what are the elements that are in A that are also, remember also, let me change this to a pen, that are also in B? And that would be A and N. How about elements that are the union of A and B? That would be all the elements in A, 1, 3, 5, 7, 8, 10, and also 2, 4, 6, 9, and 2, 4, 6, 9. Okay, so you have something like that. Okay, so these are all the elements that are in A and B. So A plus, here you can put a plus sign. Okay, A plus B, all the elements that are in A plus B. What about all the elements that are not in A? Okay, well, let me try and erase this. Never mind. Okay, so I think we can still see clearly. Okay, let us see. All the elements that are not in A would be, we know that this is A, that's A. Okay, is 8 in A? Yes. Is 10 in A? Yes. So what are all the elements that are not in A? We can start from here. We can say that 0 is not part of A. We have 12, we have 11, we have 2, 4, 6, 9. Okay, so all these elements are not in A. What about not in B? Okay, B will then be this. All right, all of this is B. So what are the elements that are not in B? They will be 1, 5, 3, 7, 11, 12, 0 as well. You see why we said you should not write 0 if there is nothing? I'm not sure where was that. Where was it? Here. Okay, we're trying to find the intersect of A and B, and there was nowhere where we couldn't find something that was in A. We couldn't find something that was in A and also in B, right? So we didn't write 0. You don't write anything. Why? Because 0 can also be an element, and so you would leave that shell empty. Okay, so I'm saying elements and shells because I'm thinking physics. Okay, so let's try and find the intersect of A, naught, and B. That means when you see the intersect, you can also just write also somewhere there. So it's something that is not in A. Not in A is all this, right? And that is in A and else that is not in A naught, sorry, that is A naught and also B. All right, so something that is A naught and also in B. So remember, so the elements that are in B, I'm just going to make a side note here. Elements that are in B are 2, 4, 6, 8, 9, and 10. Okay, so those are elements that are in B. So we'll look at the intersect of A naught and B, and that will be, we can see there's a 2 there, 2. Okay, and then we have a 4 here, and there's a 4 there, and we have a 6 here, 6 there. And what else do we have? Do we have any other numbers? 8, 9, 10. We have a 9. I wrote 2 6s. This is a 4. Okay, so 2, 4, 6, 9. All right, so that is all. Okay, so that's how you do these stuff. Okay, so I think I'm gonna stop here for now, so I don't bore you guys too much. So that is all for for today. I think what we can add here is I'm gonna draw another Venn diagram, a very big one. Okay, and I'm gonna put two elements, two sets, A and B. And I'm gonna put numbers in those sets: 1, 2, 3, 4, 4, 4, 4. Okay, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, and then 14. All right, so you can also maybe add 15. So from this set, can you find A, B, E, C? Okay, I'd like you to find the intersect of A and B. Can you also find the union of A and B? And what about A not? What about B not? That should be fun. Just comment below. You can pause here and do the answers, and just comment the answers. Okay, so that is all from me, Uno. Thank you very much for listening. UnoTutors. Tata.